Welcome to Night Lesson. Relax and learn along the way.
Intro, The Red Dream. A journey to Mars and to ourselves. Close your eyes and imagine the night sky. Not the sky of a modern city, brightened by 1,000 streetlights and neon signs, but the sky as our ancestors saw it. A velvety black sea, strewn with sparkling diamonds. Most of these points of light stand still, night after night, year after year, in the same patterns that the first humans marveled at. But a few of these lights are different. They wander. The ancient Greeks called them planet, the wanderers. And among these wanderers, there is one that has captured human attention for millennia. One whose color is different from the others. One that glows in the sky with an ominous rusty red. Mars. Tonight I will take you on a journey. Not just a journey through space, across millions of kilometers to this red planet, but also a journey through time, through the history of humanity and its eternal fascination with this distant neighbor. A story that tells of gods and monsters, of brilliant dreamers and bitter disappointments, of robots rolling lonely through red deserts, and of perhaps the greatest question we can ask ourselves: are we alone in the universe? Lean back and let yourself drift. The Red Dream begins. Chapter 1. The red star in the night sky. Many thousands of years ago, in the fertile plains between the Euphrates and Tigris, the Babylonian priests looked up to the heavens. For them, the night sky was not merely a spectacle, it was a message from the gods, written in signs of stars. And among all the lights in the firmament, there was one they watched with particular attention, a reddish, shimmering dot that moved slowly among the fixed stars. They called him Nergal, after the god of plague, war, and the underworld. His blood-red color was an omen to them, a sign of coming conflicts and catastrophes. When Nergal shone brightly in the sky, kings prepared for war. The priests tracked his course with the utmost care, for they believed they could read the future in his movements. The ancient Greeks saw the same red wanderer, and gave him the name of their god of war, Ares. For the Romans he became Mars, the father of Romulus and Remus, the protector of the legions. His symbol, the circle with an arrow pointing to the upper right, still stands for masculinity and aggression today. It is no coincidence that we still use this symbol on bathroom doors, in biological diagrams, in astrological horoscopes. But Mars was more than just a god of war in the sky. He was also a riddle that occupied the brightest minds of antiquity. The early astronomers observed something strange. At times, Mars seemed to change its direction. It did not move uniformly from east to west like the other planets, but made peculiar loops in the sky. It would wander forward, pause, wander backward, pause again, and then continue on its way. This so-called retrograde motion presented a tremendous puzzle to the scholars. How could a celestial body change its direction? In an age when it was believed that the Earth was the center of the universe, and all celestial bodies orbited it in perfect paths, this behavior of Mars was a scandal, an anomaly that called the entire worldview into question. The Greek astronomer Ptolemy tried to solve the problem by devising complicated systems of circles upon circles, so-called epicycles. In his model, Mars moved on a small circle, which in turn moved on a larger circle around the Earth. It worked, more or less, but it was inelegant, complicated, a mathematical patchwork. It was not until centuries later, when Nicolaus Copernicus and Johannes Kepler developed the heliocentric worldview, that the true explanation was found. The Earth and Mars both orbit the Sun, but at different speeds. The Earth takes 1 year for a circuit, Mars almost 2. When the faster Earth overtakes the slower Mars, it appears to wander backward from our point of view, just as a car we overtake on the highway suddenly seems to glide backward, even though it is actually moving forward. But this explanation was still far in the future. For the people of antiquity and the Middle Ages, Mars remained a mystery, a red star of war that danced to rules only the gods understood. What these early observers could not have guessed was that Mars would one day no longer be just a point of light in the sky. It would become a place, a destination, a world that we would explore with telescopes, visit with space probes, and perhaps one day set foot upon with our own feet. But the path from a god of war to a destination of human dreams was long and full of surprising turns. Chapter 2. The Age of Canals. A Dying World. The year 1877 marked a turning point in the history of Mars exploration. In that year, Mars approached the Earth more closely than it had in a long time. A so-called perihelic opposition, where the two planets were only about 56 million kilometers apart. Astronomers all over the world aimed their telescopes at the red planet, hoping to learn more about this alien world. In Milan, the Italian astronomer Giovanni Virginio Schiaparelli sat at his telescope in the Brera Observatory, meticulously drawing what he saw, and what he saw would ignite the imagination of an entire generation. On the surface of Mars, Schiaparelli discerned fine, linear structures that seemed to stretch across the planet like a web. He called them canali, the Italian word for channels or natural waterways. Schiaparelli himself was cautious in his interpretations. He never spoke of artificial structures, never of intelligence. For him, the canali were natural formations, perhaps comparable to river valleys or geological faults. But then something fateful happened. When Schiaparelli's observations were translated into English, the Italian canali became the English canals, and canals implies not natural channels, but artificially constructed waterways, a word that implies engineers, builders, intelligence. This seemingly small translation sparked a flame that set the world's imagination on fire. Among all who were fascinated by the idea of Martian canals, one man stood out: Percival Lowell. Lowell was a wealthy Bostonian aristocrat from one of New England's most distinguished families. He had studied at Harvard, traveled in Asia as a diplomat, and had written several books about the Far East. But in his mid-40s, his life changed radically. He became utterly obsessed with the idea of a Martian civilization. In 1894, Lowell used his own fortune to build an observatory in Flagstaff, Arizona, at a location he had chosen for its clear air and dark nights. The sole purpose of this observatory, the observation of Mars. The Lowell Observatory still exists today, and is one of the most important astronomical institutions in the world, although its founder is no longer famous for his Mars observations. Night after night, Lowell sat at his telescope, drawing what he believed he saw, and he saw a lot, more than any other observer. In his records, a complex network of canals appeared, covering the entire planet. Hundreds of straight lines, intersecting at certain points he called oases. His maps became ever more detailed, ever more precise, ever more convincing. For Lowell, the meaning of these structures was clear. Here was proof of a highly intelligent civilization. A civilization, however, that was doomed. Lowell developed a theory that was as grand as it was tragic. Mars, he believed, was a dying world, a planet that had once been fertile and rich in water, but had dried out over eons. Its oceans evaporated, its rivers ran dry, its atmosphere grew thinner and thinner. Only at the polar caps was there any water left, frozen in vast ice sheets. The Martians, the intelligent inhabitants of this world, were facing extinction, and in a final desperate act, a titanic engineering project, they had begun to build a planet-spanning canal system. The goal: to distribute the precious meltwater from the polar caps across the entire planet to keep the last remnants of their civilization alive. It was an epic, romantic vision, a dying race fighting against the inevitable end, heroes of survival erecting structures next to which the pyramids of Giza looked like sandcastles, a society that had overcome its differences and was fighting together for its existence. Lowell wrote 3 books about his theories: Mars in 1895, Mars and its Canals in 1906, Mars as the Abode of Life in 1908. They became bestsellers. The public was thrilled. Newspapers reported on the dying Martian civilization as if it were an established fact. But not everyone was convinced. Other astronomers using the same or better telescopes could not see the canals. They saw blurry patches, irregular markings, but no straight lines spanning the planet. The British naturalist Alfred Russel Wallace, co-discoverer of the theory of evolution alongside Darwin, wrote an entire book to refute Lowell's theories. Was Lowell a visionary explorer, or a man who saw what he wanted to see? The truth was more complicated. Lowell's telescope was good but not perfect, and the human eye has a strange tendency. When it sees blurry, fragmented patterns, it tends to connect them into lines and shapes. This phenomenon is well understood today. Lowell was indeed seeing something, but it was the limits of his own perception, not the works of extraterrestrial engineers. But no one knew that for sure at the time, and the idea of a dying Martian civilization had already embedded itself deep in the collective consciousness. It would shape the imagination of writers, filmmakers, and dreamers for generations to come. Chapter 3. The War of the Worlds. Mars attacks. The romantic vision of Lowell. Noble Martians fighting heroically against their demise had a dark side. If the inhabitants of Mars were so intelligent and technologically advanced, if their planet was indeed dying, what would stop them from seeking a new home? A planet with abundant water, with fertile land, with everything they needed to survive, a planet like Earth. In 1898, the British author Herbert George Wells published a novel that answered this question with terrifying consequence. The War of the Worlds. In Wells's story, the Martians are no longer noble engineers. They are desperate, ruthless invaders, beings with enormous heads and atrophied bodies who stomp through the English countryside in three-legged fighting machines, destroying everything in their path. Their weapons, a heat ray and a black poison gas, are hopelessly superior to human technology. Humanity is facing annihilation. Wells's novel was more than just entertainment. It was a commentary on British imperialism, a warning to a society that had itself conquered and subjugated other peoples. How would it feel, Wells asked, if someone treated us the way we treated the Tasmanians, whom we hunted to extinction? The Martians in Wells's novel were a mirror he held up to his own society. But for most readers, The War of the Worlds was, above all, one thing: terrifyingly real. The story was so convincingly written, so detailed in its description of the destruction, that many readers wondered if such a thing could actually happen. The novel became a worldwide bestseller and established a genre we now call science fiction. 40 years later, Wells's story would take on an unexpected new dimension. On the evening of October 30th, 1938, the day before Halloween, the American radio station CBS broadcast an adaptation of Wells's novel. The young director Orson Welles, no relation to the author despite the similar name, had decided to present the story in the form of mock news broadcasts. The radio play began harmlessly enough, with dance music from a New York hotel and routine weather reports. But then the music was interrupted. An excited reporter came on. A strange object had crashed on a farm in Grover's Mill, New Jersey. Not a meteorite as first thought. A cylindrical object about 30 meters long. And from this cylinder creatures were crawling out. What followed was an hour of brilliantly staged panic, reports of fighting machines rising from the ground, of heat rays setting entire cities on fire, of mass exoduses and collapsing lines of defense. The actors played reporters, military officials, frightened witnesses, and they played so convincingly that many listeners who had tuned in late and missed the announcement about the fictional nature of the broadcast believed they were actually experiencing a real invasion. The next day, newspapers reported mass panic. People had run screaming into the streets, called relatives to say goodbye, tried to flee from the Martians. The actual panic was probably less dramatic than the newspapers claimed. They too wanted to sell their copies, and a story about mass panic sold better than the truth. But the fact that anyone at all believed the story to be real showed how deeply the idea of intelligent life on Mars was anchored in the collective consciousness. Mars was no longer just a red dot in the sky. It was no longer just the home of dying philosopher-engineers. It had become a threat, a place from which monsters could come. The word Martian had become synonymous with alien. The Martians, whether as noble fighters against doom or as merciless invaders, had become part of human culture, and this idea would shape expectations when humanity finally developed the means to take a first real look at our neighboring planet. Chapter 4. The Great Disillusionment. A dead world. On October 4, 1957, a small metal ball named Sputnik beeped from Earth's orbit, heralding the space age. The Soviet Union had sent the first artificial object into space, and the United States was shaken. The race to the moon had begun, but soon eyes turned to more distant targets as well, and no target was more alluring than Mars. Both superpowers, the Soviet Union and the United States, sent probes to the red planet. The Soviets started earlier but had catastrophic bad luck. Their first Mars probe, launched in October 1960, exploded on takeoff. The second didn't even reach Earth's orbit. Mars 1, launched in 1962, lost contact halfway there. Mars seemed to resist exploration. Then, on July 14, 1965, Bastille Day in France, NASA achieved a historic breakthrough. The space probe Mariner 4, a small metal capsule with solar panels and a primitive television camera, flew past Mars at a distance of about 9,800 kilometers and sent the first close-up images of another planet back to Earth. The world held its breath. What would we see? The canals of Lowell, the ruins of a lost civilization, perhaps even signs of life, vegetation, cities, the last Martians looking up at the stars. The images that Mariner 4 sent back were a shock. The transmission took hours. Line by line, pixel by pixel, the data was received by radio telescopes on Earth. The technicians were so impatient that they didn't wait for the computers. They printed the numbers on paper strips and colored in the images with crayons, each number a different color. And what they saw was sobering. There were only 22 pictures, blurry and black and white, showing about 1% of the Martian surface. They showed no canals, no cities, no vegetation. Instead, the scientists saw a desolate, crater-strewn landscape, reminiscent of the Moon, a dead, dusty desert under a thin, hostile sky. The measurements were even more sobering. The Martian atmosphere was 100 times thinner than Earth's, little more than a wisp of carbon dioxide. The surface pressure was less than 1% of the pressure on Earth, less than at the summit of Mount Everest, less than at the highest altitude where a human can breathe. Liquid water could not exist under such conditions. It would immediately boil or freeze. No seas, no canals, no life. Disillusionment spread through the scientific community. Mars was not a dying world, it was a dead world. It had probably never been alive. The dreams of Lowell, the nightmares of Wells, the centuries-old fascination with the red planet, all seemed to be based on a misunderstanding, on the wishful thinking of a humanity that did not want to be alone in the universe. The missions of the following years initially confirmed this grim picture. Mariner 6 and 7 flew past Mars in 1969, sending more images of a moon-like wasteland. Mars, it seemed, was geologically and biologically dead, but then came Mariner 9, and everything changed. When the probe reached Mars in 1971, the largest dust storm ever observed was raging on the planet. For months the dust veiled the entire surface. But when the storm subsided, the cameras of Mariner 9 revealed a completely different world from the one Mariner 4 had shown. There were enormous volcanoes, including Olympus Mons, the largest volcano in the solar system, 3 times the height of Mount Everest. There was Valles Marineris, a canyon system stretching over 4,000 kilometers and up to 7 kilometers deep, and there were structures that looked suspiciously like dried-up riverbeds. Mars was not dead, it was just asleep. The story of Mars was not yet finished. Chapter 5, Faces in the Sand. We See What We Want to See. In 1976, 2 American space probes reached Mars, designed to explore the planet more thoroughly than anything before. Viking 1 and Viking 2 each consisted of an orbiter that circled and mapped the planet, and a lander that touched down on the surface, the first functioning spacecraft on Mars. The Viking orbiters photographed the entire planet from orbit, and one of these images would trigger a storm of speculation that has not fully subsided to this day. It was July 25, 1976. The Viking 1 orbiter was photographing a region called Cydonia, a plain in the northern hemisphere of Mars. On one of these images, taken from an altitude of about 1,800 kilometers, a formation appeared that immediately caught the scientists' attention. A structure that bore a startling resemblance to a human face, 2 dark spots that looked like eyes, an elongated ridge reminiscent of a nose, a horizontal line that looked like a mouth, a face on Mars. NASA released the image as a curiosity, an interesting example of how light and shadow can create strange shapes. One scientist joked that the face seems to be staring at us. The official explanation was sober: a natural hill about 1.5 kilometers long, whose appearance was created by the low-lying sun and the limited resolution of the camera to give the impression of a face. But for many people, this explanation was unsatisfying. The face on Mars became an icon. Books were written, documentaries were made, websites were created. Some saw in the formation proof of a lost Martian civilization, a monument erected by beings who may have even looked like us, a message to future visitors, a sign: we were here, we lived here. Others discovered more structures in the vicinity of the face: pyramids, geometric patterns, regular arrangements, the remains of an alien city. The longer one looked, the more one seemed to find. The theories became more and more elaborate. Some believed the face was a message to future visitors to Mars. Others suspected that NASA was deliberately hiding evidence of extraterrestrial intelligence, a cover-up of cosmic proportions. The truth would not come to light for more than 2 decades. In April 1998, the Mars Global Surveyor probe photographed the same region with much higher resolution, 10 times sharper than the Viking images, and what it showed was unequivocal. An ordinary hill, weathered, eroded, shaped by wind and time, in the full light of day, photographed from different angles, there was no longer any sign of a face, just a few rocks, a few shadows, a hill like 1,000 others on Mars. Later images from the Mars Reconnaissance Orbiter confirmed the picture with even greater clarity. The face had disappeared, or rather it had never been there. What had happened? How could so many people see such a clear face in a pile of rock? The answer lies in a phenomenon called pareidolia, the tendency of our brain to recognize familiar patterns in random shapes, especially faces. It is a remnant of our evolution. For our ancestors, it was vital for survival to recognize faces quickly. The face of an enemy, a friend, a predator in the undergrowth. Better to see a face where there is none one too many times, than to overlook a face where one is lurking one too few times. Our brain is so well trained to find faces that it sometimes sees them where there are none. We see faces in clouds, in tree bark, in the craters of the moon, in slices of toast and water stains. And we see them on Mars. The story of the face on Mars is strangely reminiscent of Percival Lowell and his canals. Lowell saw lines where there were none because he wanted so badly for there to be lines. We saw a face because we wanted so badly for there to be a face. Both times it was our own brain playing a trick on us. Mars remains what it has always been, a mirror of our hopes and desires. We project onto its red surface what we want to find: civilizations, monuments, meaning. But perhaps the true meaning lies not in what we find there, but in what the search reveals about ourselves. Chapter 6, Whispers in the Red Sand. The search for water while the face on Mars captured the public's imagination. Scientists were working on a much more fundamental question. Was there ever life on Mars? And if so, could it still exist today, perhaps deep beneath the frozen surface? The Viking landers of the 1970s had conducted complex experiments to search for life. The first and to this day the only experiments aimed directly at discovering microorganisms on another planet. 3 different experiments were carried out. The labeled release experiment was the most promising. Martian soil was mixed with a nutrient solution containing radioactively labeled carbon atoms. The idea was simple. If microorganisms lived in the soil, they would digest the nutrients and release radioactive carbon dioxide in the process. And that is exactly what happened. The instruments registered a release of gas, just as one would expect if microorganisms were digesting the nutrients. But the euphoria was short-lived. Another experiment, which searched for organic molecules, the basic building blocks of life, found nothing. No amino acids, no hydrocarbons, none of the complex compounds that characterize terrestrial life. The Martian soil seemed to be sterile, more sterile than the driest deserts on Earth. The explanation was sobering. The Martian soil contains reactive chemicals, so-called peroxides, that decompose organic substances and could explain the observed gas emissions without life being involved. The reaction was chemical, not biological. Or was it? Gilbert Levin, the scientist who had designed the labeled release experiment, remained convinced for the rest of his life that his experiment had indeed detected life. Until his death in 2021, he argued that the Viking landers had found Martians, tiny microbes living in the red sand. Most scientists disagree. The question remains open. The Viking results are still controversial today. In the aftermath, NASA developed a new strategy for Mars exploration, summarized in 3 simple words. Follow the water. The logic was compelling. All life as we know it requires liquid water. Without water, there are no cells, no metabolism, no DNA. If we want to understand whether life ever existed on Mars, we need to understand whether water ever existed there. Then something unexpected happened. In August 1996, NASA held a press conference that sent an earthquake through the scientific world. At the center was an inconspicuous rock, a meteorite that had been found in Antarctica in 1984 by a geologist named Roberta Score. It weighed about 2 kilograms and bore the catalog number ALH 84001 ALH for Allen Hills, the region where it was found. This meteorite was special. Chemical analysis had proven beyond a doubt that it came from Mars. The history of this stone was epic. About 4 billion years ago, it formed from the magma of the young Mars. About 16 million years ago, it was flung into space by a massive meteorite impact. For millions of years, it drifted through the inner solar system, a silent message in a bottle from a distant world. And about 13,000 years ago, it landed in Antarctica, where it was preserved in the ice until Roberta Score found it. In this Martian rock, scientists had discovered something that held the world breathless. Tiny worm-like structures, only about 100 nanometers long, 1,000 times thinner than a human hair. They resembled fossilized bacteria. In addition, there were minerals and chemical compounds that could indicate biological processes. President Bill Clinton addressed the nation. Live from the White House, "If this discovery is confirmed, it will surely be one of the most stunning insights that science has ever uncovered about our universe. Its implications are as far-reaching and awe-inspiring as can be imagined. Had we finally found proof of extraterrestrial life? The answer is, we don't know." The scientific community remains divided to this day. Many researchers argue that the structures in ALH 84001 could also have been formed by non-biological processes, through crystal growth, chemical reactions, even through contamination with terrestrial microbes after it landed. The Martian rock remains a puzzle, a state of limbo between hope and skepticism, a question mark at the end of a very long sentence. But regardless of this one stone, the following decades revolutionized our understanding of Mars. A new generation of robotic explorers landed on the red planet and unveiled a surprising past. On July 4, 1997, American Independence Day, the Pathfinder probe landed on Mars and released a small rover named Sojourner onto the surface. Sojourner was hardly bigger than a shoebox and weighed only about 10 kilograms. It was slow, primitive by today's standards, and could only move a few meters from its lander. But it was the first mobile robot on another planet. Then came Spirit and Opportunity, the legendary twin rovers that landed on opposite sides of Mars in January 2004. They were larger than Sojourner, about the size of golf carts, equipped with cameras, spectrometers, a microscope, and a drill. Spirit landed in Gusev Crater, a huge impact basin that was once traversed by a massive channel. For 6 years it explored the surroundings until it got stuck in the soft sand of a region called Troy in May 2009. Engineers tried for months to free it, but in vain. Spirit became a stationary research station until a harsh Martian winter destroyed its electronics. Opportunity landed in Meridiani Planum, a flat plain on the other side of the planet. Originally designed for a 90-day mission, it rolled across Mars for nearly 15 years, the longest marathon ever completed by a robot on another planet. It traveled over 45 kilometers, more than the distance of an earthly marathon. In 2018, a massive dust storm swept across Mars, darkening the entire planet. Opportunity's solar panels could no longer receive light. The rover ceased operations. For months, engineers tried to make contact. In February 2019, NASA sent one last message, a radio song, Billie Holiday's "I'll Be Seeing You," a farewell to a faithful friend who had shown us so much. What these rovers found changed everything we thought we knew about Mars. They discovered layers of rock that can only form in the presence of standing water, dried-up riverbeds and deltas where streams once flowed, minerals like hematite, small spheres that scientists affectionately called blueberries, which on Earth only form in moist environments, sulfates and clays deposited by water. Mars had not always been dead. More than 3 billion years ago, it was a different world, warmer, wetter, with a denser atmosphere. Rivers flowed through its landscape, some as wide as the Amazon. Lakes filled its craters, some as large as the Great Lakes of North America. Perhaps an ocean even covered its northern hemisphere, a sea larger than the Atlantic. The question was no longer, was there water on Mars? That question had been answered. Yes, there was water, a lot of water. The new question was, if there was water, was there also life? The search continues. Chapter 7. The Moons of Fear, the Riddle of Phobos. Before we turn our gaze to the future, we must make one more detour to 2 small celestial bodies that accompany Mars, and whose history is almost as fascinating as that of the planet itself. Mars has 2 moons, and their names could not be more fitting. Phobos and Deimos, fear and terror, the mythological sons of the war god Ares, who accompanied their father into battle. They were discovered in 1877, the same year Schiaparelli saw his canali, by the American astronomer Asaph Hall at the Naval Observatory in Washington. These names are no exaggeration. Phobos and Deimos are not majestic moons like our own silver companion, which illuminates the night sky and governs the tides. They are small, irregularly shaped boulders, looking like giant potatoes tumbling through space. Phobos, the larger of the two, measures only about 27 by 22 by 18 kilometers. Smaller than many terrestrial cities. Deimos is even smaller, barely 15 by 12 by 11 kilometers, a cosmic grain compared to our moon. Yet despite their modest size, these moons are sources of great mystery. Let's start with Phobos. It orbits Mars at a distance of only about 6,000 kilometers from the surface, closer than any other known moon orbits its planet. So close that it circles Mars faster than the planet rotates on its own axis. A day on Phobos lasts only 7 hours and 39 minutes. This leads to a bizarre phenomenon. Seen from the Martian surface, Phobos rises in the west and sets in the east, the exact opposite of all other celestial bodies. It wanders backward across the sky, twice a day, a ghostly companion that seems to defy the laws of intuition. This close orbit has consequences. The tidal forces of Mars are slowly pulling Phobos inward, about 2 centimeters per year. In cosmic terms, that's incredibly fast. In about 50 million years, it will come so close to the planet that the tidal forces will tear it apart, either into a spectacular ring like Saturn's, which will adorn Mars for a few million years, or it will crash onto the Martian surface as a rain of debris, leaving behind a massive crater. But the real mystery of Phobos lies in its physical properties. Scientists have calculated the density of Phobos, and the result is surprising, about 1.9 grams per cubic centimeter. That's less than most types of rock, less than granite, less than basalt, less than most meteorites. Such a low density suggests that Phobos is either made of very light material, perhaps a mixture of rock and ice, or that it is full of voids, riddled with cracks and caverns like a cosmic Swiss cheese. In the 1960s, this finding led the Soviet astrophysicist Iosif Samuilovich Shklovsky to a sensational speculation. What if Phobos is hollow? And if it is hollow, could it be artificial? An abandoned spaceship of an ancient civilization orbiting Mars for eons? Shklovsky was no crank. He was a respected scientist who had made important contributions to radio astronomy. His reasoning was purely scientific. The observed properties of Phobos, its low density, its unusual orbit, were most easily explained if the moon were hollow. And a natural body could not be hollow. The idea was provocative and quickly became the stuff of science fiction dreams. An alien spaceship, disguised as a moon, silently and deserted, tracing its orbits for millions of years, waiting to be discovered. The more likely explanation is less romantic but hardly less interesting. Modern measurements show that Phobos is probably a rubble pile, a heap of debris, dust and perhaps ice, held together only loosely by its own weak gravity. Millions of years of meteorite impacts have made it porous, riddled with cracks and cavities. Up to 30% of its volume could be empty. But the mysteries don't end there. Spectral analysis of the surface of Phobos shows that it is extremely dark. It reflects only about 7% of the incident light, darker than coal. The chemical composition is reminiscent of carbon-rich C-type asteroids, the oldest objects in the solar system. But some measurements point to unusual minerals, to compounds that do not fit this picture. And in some images, areas of the surface seem to have an almost metallic sheen, reflections that fueled speculation but are probably just due to special minerals or freshly exposed rock layers. Then there is the curse of the Phobos missions. Almost every space probe that was supposed to study Phobos up close has failed. Phobos 1, launched in July 1988, lost contact on its way to Mars. A software error had accidentally shut down the attitude control system, and the probe tumbled out of control. Phobos 2 actually reached Mars orbit in January 1989 and sent fascinating images, including infrared shots that showed thermal anomalies on the Martian surface. One of the last images showed a mysterious, elongated shadow that still occupies conspiracy theorists today. Was it an alien spaceship? An optical illusion? A cloud? Then, just before the probe was about to get very close to Phobos, contact was lost. A computer error, the engineers said. The most ambitious mission was Phobos ground in 2011. It was supposed to land on Phobos, collect samples with a drill, and return them to Earth. It would have been the first sample return from a Martian moon, a historic milestone. The probe launched successfully on November 9, 2011. But then the upper stage failed. Phobos grunt didn't even make it out of Earth orbit and crashed back to Earth 2 months later into the sea. Is there a Phobos curse? Of course not. Space travel is just hard, especially for Russia after the collapse of the Soviet Union, and failures are common. But the accumulation of failures has done nothing to diminish the mystique of this strange moon. And then there is the monolith. On high-resolution images from the Mars Reconnaissance Orbiter, taken in 2008, scientists discovered a conspicuous boulder on the surface of Phobos. A solitary, towering stone, about 90 meters high, casting a long shadow across the dusty surface. The scientific explanation is prosaic. Probably a piece of rock that was exposed or pushed upright by an impact, a natural phenomenon on a celestial body with no atmosphere and no erosion. But it inevitably brings to mind the black monolith from Stanley Kubrick's film 2001. A Space Odyssey, that mysterious cuboid that drives human evolution. Buzz Aldrin, the second man on the moon, once mentioned the Phobos monolith in a television interview. There's a monolith on Phobos, a very unusual structure. People are going to ask, who put that there? The universe put it there, but we should go and look at it. The quote was often taken out of context. Aldrin was advocating for manned exploration of Phobos, not for aliens, but it fueled further speculation. Phobos remains a riddle. Is it a captured asteroid that fell into Mars's orbit billions of years ago? Is it a remnant of a cosmic collision, a piece of Mars itself that was hurled into space by a massive impact? Where does its dark material come from? Why is its density so low? The planned Japanese mission MMX, Martian Moons Exploration, is set to finally provide answers in the coming years. It will fly around Phobos and Deimos, study the moons up close, and for the first time bring samples from Phobos back to Earth. Perhaps these few grams of dust will solve one of the greatest mysteries of our solar system. Until then, the Moon of Fear continues to circle its red planet, a small potato-shaped lump full of secrets, rising in the west every night. Chapter 8. The next great leap. As you listen to these words, robots are rolling across Mars. They are our eyes and hands on a foreign world, ambassadors of humanity, and they are making history. Curiosity, the rover that landed in one of the most spectacular maneuvers in space history in August 2012, is a mobile laboratory the size of a small car, weighing almost a ton, powered by a plutonium reactor that guarantees it decades of energy. With its laser beam, called ChemCam, it vaporizes rock from several meters away to analyze its composition. With its drill, it takes samples from the subsurface and analyzes them in its built-in chemistry lab. For over a decade, Curiosity has been climbing the slopes of Mount Sharp, a massive mountain in the center of Gale Crater. Layer by layer, it reads the climate history of Mars. Like a geologist turning the pages of a petrified book, it has found evidence of ancient riverbeds, of lakes that once filled the crater floor, of times when Mars was warm and wet. Perseverance, its younger cousin, landed in February 2021 in Jezero Crater, a dried-up river delta that was fed by a river more than 3 billion years ago. It is one of the most promising places to search for past life, because on Earth, river deltas are places where organic material accumulates, preserved in fine sediments. Perseverance's mission is even more ambitious than Curiosity's. It collects rock samples and seals them in small titanium tubes, each about the size of a lipstick. These tubes are deposited at various locations, like a treasure hunter leaving clues. A future mission, still in the planning stages, is intended to collect these samples and bring them to Earth. They would be the first samples from another planet that humans have ever held in their hands. And then there is Ingenuity, the small helicopter that traveled to Mars with Perseverance. Ingenuity is a marvel of engineering. weighing only 1.8 kilograms with rotor blades that have to spin 5 times faster than on Earth to generate enough lift in the paper-thin Martian atmosphere. When it first spun its rotors on April 19, 2021, and rose into the thin Martian air, just 3 meters high, for 39 seconds, it was a Wright brothers moment on another planet. The first powered flight in another atmosphere. A piece of fabric from the Wright brothers' plane was on board, a relic from one historic moment to the next. Originally designed for 5 test flights, Ingenuity completed over 70 flights, proving that flight is possible even in the whisper-thin Martian atmosphere, 1% as dense as on Earth. Future Mars helicopters could explore areas inaccessible to rovers, fly over canyons, and reach mountain peaks. But all these robots are only precursors, forerunners for what is to come, humans on Mars. It is no longer just a dream of science fiction writers, no longer just a vision for distant generations. It is a concrete goal that engineers and scientists around the world are working on. NASA is working on the Artemis program, which will first return humans to the Moon for the first time since 1972. But Artemis is only the first step. The Moon is intended to serve as a training ground, a stepping stone for the real challenge, a manned mission to Mars. SpaceX, Elon Musk's space company, is developing the Starship, a massive spacecraft, the largest and most powerful ever built. In its founder's vision, this spaceship will one day not only take people to Mars, but establish a permanent colony there, a second home for humanity. China has announced plans to send people to Mars in the 2030s. Europe, Japan, the United Arab Emirates, all have Mars programs. All are working on technologies that could one day take people to the red planet. The challenges are immense. A journey to Mars takes 6 to 9 months, depending on the alignment of the planets. The astronauts would be exposed to cosmic radiation, from which they are protected on Earth by the magnetic field and the atmosphere. Every day in space increases the risk of cancer. They would have to live in a confined spacecraft, far from any help, dependent on every system functioning. A radio call to Earth would take up to 24 minutes. In an emergency, no one could intervene. And when they arrive, Mars is not a second Earth. Its atmospheric pressure is so low, less than 1% of Earth's, that blood would literally boil if exposed without protection. The average temperature is minus 60 degrees Celsius, with lows of minus 125 degrees at the poles. The soil contains toxic perchlorates that damage the thyroid gland. There is no oxygen to breathe, no liquid water to drink, no food to eat. Everything would have to be brought along or produced on site, and yet people are working on it. Engineers are designing habitats that could be built from Martian soil, printed with 3D printers that need only sunlight and Mars dust. Scientists are developing MOXIE, a device already being tested on Perseverance that extracts oxygen from the carbon dioxide atmosphere of Mars. Psychologists are studying in isolation experiments on Earth how people could endure years of solitude and confinement without going mad. It will not be easy. There will be setbacks, perhaps tragedies. But if the history of humanity shows one thing, it is that we have always gone further, further than we had to, further than was reasonable. Out of Africa to all corners of the world, across the oceans to the Moon, and one day to Mars. Outro. At the end of this journey, we return to that red dot in the night sky where it all began. To the Babylonians, he was Nergal, a god of war and plague, whose appearance foretold disaster. To Percival Lowell, he was the home of a dying civilization, of noble engineers fighting against the inevitable. To H.G. Wells, he was the origin of an alien invasion, a place of terror. To the scientists of Mariner 4, he was a cold, dead desert, a graveyard of dreams. And today, we know that Mars was once a different world, a world with rivers that flowed through valleys, with lakes that filled craters, perhaps even with an ocean that covered its northern hemisphere. Whether life ever arose in that water, tiny microbes thriving in warm springs or surviving under the ice, we do not know. But the search continues, with every rover that draws its tracks in the red sand, with every grain of rock that is analyzed, with every image that is beamed across the void of space to Earth. We saw canals where there were none. We saw faces where there were only rocks. We saw messages where only shadows played. Mars is what it has always been, a mirror in which we recognize our own hopes and fears. Perhaps that is the deepest truth about our fascination with the red planet. It shows us not only what is out there, it shows us who we are. a species that cannot stop dreaming, that cannot stop asking questions, that lifts its gaze to the starry sky and refuses to accept that the answers are unreachable. One day, people will stand on Mars. They will wade through red sand, look up at a butterscotch-colored sky, and know that they are farther from home than any human has ever been. They will see mountains higher than anything on Earth, canyons deeper than the Grand Canyon. And at night, when the stars twinkle, the same stars we see, just a little brighter, a little closer, they might look up, and there in the distance they will see a small blue-white dot shining in the blackness. Earth, our home. The first person to see this sight may weep, not from sorrow, but from awe, from the feeling of being part of something greater than all of us, from the knowledge that we did it, that we made it from a blue dot to a red dot across the void, carried by nothing but our dream. That is what Mars teaches us in the end. Not just that we can look outward, but that in doing so, we learn to look inward. That exploring the unknown helps us to understand ourselves, that only from a distance do we see how precious and fragile our little blue marble is. The red dream was always a journey to ourselves, and this journey is far from over. Sleep well. Dream of red deserts and distant horizons, of robots rolling lonely through craters, of people leaving footprints in alien sand, and maybe, just maybe, you'll dream of being there yourself one day. That was today's night lesson. Thank you for listening. If you'd like to see more videos like this, please leave a like and subscribe to the channel. Good night and sleep well.